Good morning, Honors Math 3. Today is Wednesday, March 18th. It is Jersey Day. You might not be able to watch a sport today. You might have to play a sport today. Celebrate with us. Tomorrow's workout day, Friday, Hawaiian day. You should have printed before we get started these notes. Task 7.2, we're going to talk about arithmetic sequences today, which should be familiar to you. Back for Math 1, today is 3/18/20. An arithmetic sequence occurs when the difference between consecutive terms is always the same. Here's two nice sequences. An arithmetic sequence might be something like 3, 8, 13, 18, and so on, because there's a common difference between terms. What's the difference between terms? 5, 5, 5. Here's a sequence that is not arithmetic. 2, 9, 28, 65. There is a pattern to the sequence. You can try to find it. But the difference between terms is not the same. So it's not an arithmetic sequence. The terms of an arithmetic sequence, beginning with a sub 1 and with a common difference of d, follow a pattern. First term is a sub 1. Next term is a sub 1 plus that common difference. If I add that common difference again, I get a sub 1 plus 2 of those differences. If I add that difference again to the fourth term, to get the fourth term, I would be at a sub 1 plus 3 of those common differences, and so on. That will lead to an important pattern for the general term very soon. For this sequence, 5, 1, -3, -7, what is a sub 1? And what is the common difference? A sub 1, of course, is our starting point. Jot it down. What's the common difference between those terms? You can start to see the pattern. The reason we call it a difference is because you can always take a term and subtract the previous. Term and subtract the previous. Take a term, subtract the previous, and you're left with that common difference. In this case, the difference is -4. And it's a nice arithmetic sequence. You can show that a sequence is or is not arithmetic. I'm going to pause for a second. Can you list the first 5 terms of that sequence? What are the first 5 terms of that sequence, starting with S sub 1? I'm going to pause. Okay, so I plugged into that formula for the general term, and I found that the first 5 terms of that sequence are 3, 1, -1, -3, and -5. If I subtract the previous from a term, I get -2, -2, -2, -2, and yes, that function is arithmetic. We can derive a formula for the nth term for an arithmetic sequence. Again, some of this might look familiar from Honors Math 1. If the first term of an arithmetic sequence is just a sub 1, and then I add to it that common difference, I get a sub 1 plus d. If I add another d, I get a sub 1 plus 2 of those differences we saw before. If I just add another common difference, a sub 1 plus 3d, a sub 1 plus 4d. Take a second and look at that pattern. If I asked you for a formula for a sub n in general, second term a sub 1 plus 1d, third term a sub 1 plus 2d's, fourth term a sub 1 plus 3d's, pause for a second and see if you can see that pattern. And this leads us to a formula for the general term of an arithmetic sequence. Notice we always start with a sub 1, and we always add. For the third term, only 2 differences. For the fourth term, only 3 differences. For the nth term, I'm always going to have 1 less of those common differences. No difference in the first term. There's always 1 less of those differences. So if the first term of an arithmetic sequence is 25, the common difference is -3, can you find the 100th term, a sub 100, of an arithmetic sequence? For an arithmetic sequence, we can. We start with a sub 1, and we always add 1 less of those common differences. So the 100th term of the sequence will be the first term, 25, plus I'm only going to have 99 of those common differences. No common difference in the first term. I'll only have 99 of those common differences. grab your calculator. What is that? 25 plus, and I get negative 272, but you can confirm. Alrighty. Let's look at a few more cases where we can use that formula for the general term. I'll get you started, and I'm going to pause here and there so you can think through a few things. Can you find the 80th term of the sequence, a sub 80, using that general term formula? Please take a moment. Okay, again, using that formula for the common difference, the 80th term will be the first term, negative 1, plus only 79 of those differences. What is the difference between terms? I'm adding 3, my common difference is 3. Do that calculation. I get the 80th term of this sequence is 236. What would you do with this? Can you find a formula for the nth term? So a sub n is always the first term plus n minus 1 differences. If the fourth term is 3 and 20th term is 35. So a sub 4 is 3 and a sub 20 is 35. Pause for a minute and think about what you can plug in. Okay, thanks for thinking about it for a minute. Typically we say, well, what's the difference between these terms we're given? The fourth term is 3, the 20th term is 35. What's the difference between those? So that's 35 minus 3. But what's the difference? How many terms is that? So that would be all of those common differences between the fourth and the 20th term. How many terms is that? That's really divided across 20 minus 4, 16 terms, 35 minus 3. So the common difference is 2. So that gives us the common difference. And then I start plugging in. Formula for the nth term, a sub n, equals a sub 1 plus n minus 1 times the difference of 2. But I don't know what the first term is. So now I need to find a sub 1. Pause for a second and see if you can find that. I might do something like this. Remember, we're given the fourth term is 3. How would you calculate the fourth term? The fourth term would be the first term plus 1 less of those differences. But now we know the difference. Oh, wait, and we know the fourth term. The fourth term is 3, will equal a sub 1 plus 3 of those common differences, and the common difference was 2. So 3 is equal to a sub 1 plus 6. A sub 1 must equal negative 3. And now I can find a formula for the nth term. Plugging all that in, the nth term will always be the first term, negative 3, plus, can I distribute here and I'll simplify this? 2n minus 2. And here's a formula for the nth term of that arithmetic sequence. I might call that 2n minus 5. We'll start to see arithmetic sequences are always of a certain form. Can you try that one more time? Find a formula for the nth term, and then you should be able to find the 75th term of that sequence once you have a formula for that nth term. So the 5th term is 12, 17th term is 16, and first I'm going to find a formula for the nth term. Can you start to plug into that formula? Okay, first we can find that common difference. The difference between all of those given terms is 16 minus 12. How many terms, how many differences would that be between the 17th and the 5th term? Gives me 4 over 12, gives me a common difference of 1/3. So the common difference is 1/3. Let's start to plug that in. So a sub n will equal a sub 1 plus n minus 1 of those differences. But then we have to find that first term. So find a sub 1. How did we find a sub 1? I might use the fact that a sub 5 is equal to 12. So 12 will equal the first term plus, for the 5th term, I would only have 4 of those common differences, and my common difference was 1/3. So 12 will equal a sub 1 plus 4/3. I can subtract 4/3 from both sides, and a sub 1 is equal to, what is that in thirds? 36/3 minus 4/3, which is 32/3. If I plug that all in, so what's my a sub 1? 32/3. I can find the 75th term of that sequence. I'm going to pause, do a little calculation there. All right, first term plus 74 of those thirds, 74/3, and I get 106/3. for my 75th term of that sequence. Alrighty, it's important to be able to find the sum of an arithmetic sequence of these special patterns. The sum of an arithmetic sequence, the sum from k equals 1 to the nth term of an arithmetic sequence. We have a special formula to find the sum of an arithmetic sequence is always the number of terms divided by 2 times the first term plus the last term in that sum. Find the sum of an arithmetic sequence given that the first term is 15, common difference is -7, and there's 23 terms in that sequence, or 23 terms that we're trying to add up. So I want to find the sum. I'm going to use that notation. The sum of the first 23 terms is always the number of terms we want to add, 23 divided by 2, times the first plus the last, in this case, a sub 23. Let's continue plugging into that formula. Number of terms divided by 2 is 23 divided by 2 times the first, but we're given the first term is 15 plus a sub 23. Unfortunately, I don't know a sub 23, but we have a formula to find a sub 23. So let's use that formula. The 23rd term of that sequence will always be the first term plus 1 less 22 differences, and the difference is -7. So I have an easy formula to find the 23rd term of that sequence, which, do that calculation if you would, is a -139. If I plug into my formula for a sum, use your calculator, and that sum comes out to be -1426. If I add up the first 23 terms of that sequence, I'll get -1426. Okay, find the sum of this next sequence. Again, I'm going to use the formula that the sum of an arithmetic sequence is the number of terms divided by 2 times the first plus the last. Notice this is just a sum in general up to the nth term. For whatever term, I'm going to find the sum of this. Is this sequence actually arithmetic? Do you see the pattern? Yep, it's increasing by 4, increasing by 4. So the sum of any n terms of the sequence will be the number of terms in general divided by 2 times the first, I'm given a sub 1, plus the last, whatever that last term is, 4n minus 5. Let's just simplify that again a little bit. S sub n is equal to n over 2 times, what is that, 4n minus 6. That implies that S sub n, let's see, I can divide those both by 2, equals n times 2n minus 3. Here's a formula to find the sum of any n terms of this arithmetic sequence. If I distribute 2n squared minus 3n. And it's a formula to find the sum in general for any n terms of that sequence. All right, let's draw a little picture here. Corner section of Soldier Field has 15 seats in the first row and 18 rows in all. Okay, so let's see. Each successive row contains 2 additional seats. So as I move back for these 18 rows, this is an arithmetic sequence. First row, and then I add 2 to get the number of seats in the next row, and so on. I keep increasing each row by 2. How many seats are in this section? Is this an a sub n question or a sum section? Pause for a second. Okay, if we're asked just how many seats are in this section, that is a sum. It's the sum of what? It's the sum of the first 18 rows, so that's my n. Will always be the number of rows divided by 2 times the first. I'm given a sub 1 is 15, plus the last. The problem is I don't know what a sub 18 is. So a sub 18 will always be the first term plus 1 less of those differences. So what is a sub 18? A sub 18 is 49. Plug into my sum formula, pick up your calculator. How many rows in that corner section? How many seats in that corner section? 576 seats. All right, go throw a jersey on, play, do something outside and active today. I'm going to assign the 7-2 homework. I'm going to assign the odds today. I'll probably do a little video of homework help if you have questions on those, and then I'll assign the evens for Thursday. And that'll round out our new material for this week.